This lesson is my addendum to my other lesson on GERMDAS, in which I go into much more detail about what's going on in this picture at the top, this little cheat sheet about how we are going to follow the order of operations for arithmetic and for algebra. So I'm going to use a lot of the things that I did in that lesson and just kind of assume you've already watched that and know it. So if not, the link is in the description to the main lesson. Watch that first. But this is the kind of equation that we still need to be really careful with how we go through it. We need to follow the order of operations, but there's lots of little kind of side quests involved. It's a complicated thing. So I'm going to show you how I think about this. I'm going to talk fast. I'm going to write fast. Slow it down if you need to, but all of this wouldn't be really necessary on the SAT, because if it were a real SAT question that gave me this equation and asked me to solve for X, I would just put it in the calculator into Desmos and it will solve it for me, and I will show you that at the end. But if I'm looking at this and I have to do algebra for some weird reason, I am going to think about GERMDAS. And so the first thing I'm going to do is on each side, I'm kind of thinking about a mini GERMDAS, because my first move is to simplify arithmetic. So I want to go forwards through it, and I need to kind of think of each side separately as its own little mini simplification step, right? So I'm not moving anything across the equals until I absolutely have to. If I can condense things on one side, I'm going to do that first. I'm going to make it simpler so that when I move things, there's less stuff to get lost. So first I'm looking, is there a grouping? Yes, there's a grouping here on the left under the radical. Inside of that grouping, I'm doing a mini GERMDAS, right? Is there any exponents or radicals there? No. Multiplication or division? No. Yes, though, there is addition and subtraction. I can combine the 10 and the 5. So I end up with 10. See, I already messed it up here. We're going to end up with x plus 15 minus 1, right? I haven't changed that, so that's going to stay outside, and we're not even going to bother writing the right side yet. Let's just keep it as that. Now, I've taken care of my g, right? So that worked. Are there any exponents or radicals? Yes, there is a radical, but I can't do anything with it because x plus 15 is inside of it. And even if 15 was a nice number that I could take the square root of, I couldn't do it because it's being added to the x. And when you have exponents and radicals mixing with addition and subtraction, you're kind of hitting a lot of barriers. There's very limited things you can do. So we're not really able to do anything else here. So there are no exponents or radicals that we can do anything with. There's no multiplication or division. There is addition and subtraction here, but again, that 15 is inside the radical. It's inside a grouping that I can't touch yet, so I can't combine it with the -1. So this side is fully simplified. Moving over to the right, are there any groups? Yes, x plus 7 is a group. X plus 12 is a group, but I can't do anything with that because x and 7 can't be added. X and 12 can't be added. Thankfully, there's no exponents or radicals, but there is multiplication and division. So I'm going to do that. And in this case, because I can't do anything with the groups and kind of like simplify them any further, I'm going to try to break them apart by doing distribution. So we get 2x plus 14. There's also some distribution to do here. Remember that if we have a minus in front of a parentheses, it's a -1. So we have to distribute that negative. So this is minus x minus 12. So is there any more multiplication or division on just the right side? No. So that is done. Check. And the grouping is done. So now we move on to addition and subtraction. Can I combine like terms using addition and subtraction? Yes. 2x and -x is x, and 14 and -12 is 2. So that is done. Now there's still addition here, but I can't combine x and 2 because they're different kinds of things. So we've reached the limit. I'm going to rewrite this side here, but this is the end for now of my simplify arithmetic steps, right? So notice nothing has moved across the equal signs yet. I saw some obvious places where I could do that, but I'm not going to try to do 2 steps at once. That is a big mistake. That is where careless mistakes happen. We're doing things one at a time. Take the time to do them one at a time, and you will not make as many careless mistakes. But now we have to move to step 2, which is to solve. We're going to move backwards now through GERMDAS, trying to solve this thing, and we have to start moving things across the equal sign. So again, I'm thinking about GERMDAS, but now I'm working backwards. And ultimately, the thing here that I'm kind of planning ahead is that I have a grouping that is a radical right here. And this is a problem. This is going to be the biggest pain in the neck of this question. So I know that the only way I can deal with it is to make it go away, right? ER, make them go away, exponents and radicals. And so I want to make it go away, but I can really only do that by squaring it, because to get rid of a radical, you want to square a square root. But I don't want to have to do that with that -1 there, because then things get really messy. It's doable, but it's going to create more problems than it solves. So in order to eventually get to a place where I can continue to solve, I need to recognize that I want that grouping to kind of get broken down. So once I do that, I can start to simplify again. But in the meantime, I need to get that grouping alone. So I'm going to add 1 to both sides. I'm going to do this addition subtraction step. I'm going to add 1 to both sides. And as I do that, all that moves is the -1. And it becomes a 3, because what are we really doing here? On the left, we are making zeros, right? That's our point when we do addition and subtraction. We want to do that. And so now I'm kind of working backwards. Addition, subtraction is done. Is there any multiplication or division? No. Are there any exponents or radicals? Yes, this group. So we're going to split it apart, and we're going to do that by squaring both sides. Now on the left side, that's really nice and easy, right? We're breaking this group up. We're getting an x plus 15. But on the right side, we're making a group, right? Because if I square this thing, I have to square everything. And so x plus 3 squared is now a new group. And so we were like, well, you solved one grouping problem, but you've created another. Yes, but there's kind of a hierarchy in our order of operations. I'd rather have exponents than radicals in most cases. I'd rather have multiplication than division in most cases. And yes, I would rather have addition than subtraction in most cases. So I'm kind of always trying to think, if I have kind of 2 bad options, an exponent is a better option than a radical. So we've gotten rid of the worst thing. We have created a little bit of a problem, but the good thing about an exponent like a squared is it's just multiplication. So one thing that's I said this kind of before, is we're going to have a lot of trouble in algebra trying to mix exponents and radicals with addition and subtraction, because they're just kind of too far removed. Like even just looking at the word GERMDAS, there's some stuff in between, right? Multiplication and division is the bridge between those things. So I can move between multiplication and division and addition and subtraction pretty easily. But if I go too far, it's harder to mix them. So really what happens here is I have to make sure I don't treat that exponent like multiplication and distribute it. Instead, I have to FOIL, and I have to break that group apart by multiplying. So really what I'm doing here is I have x plus 3 times x plus 3. And now I've kind of reset the clock. I'm actually back to step 1. I'm back to a place where I have things that I want to simplify on both sides. So I've kind of paused my algebra, I've paused my solving, and now I'm doing a little bit more of a simplification step. So I'm going to FOIL, I'm going to expand this. So let's keep the x plus 15 where it is for now. Don't do 2 steps at once. We're going to FOIL, so we get x squared plus 3x. I'm doing this in a kind of weird way. Plus this 3x plus 9. And again, I can still simplify, right? I just did a bunch of multiplication, right? So GERMDAS, we did some multiplication division. Now we do addition, subtraction, and we can add these things together. So x plus 15 equals x squared plus 6x plus 9. So we're moving through. We are moving through in a way that is still very consistent with the rules of GERMDAS. Now, I'm at a point again where I can't do anything. I can't simplify anymore, right? Now the x squared, the 6x, the 9, those can't be added. The x and the 15 on the left side, they can't be added. I have to move things across an equal. So I'm back to doing solving, to moving backwards through GERMDAS and trying to get things to a good place. So regardless, we would start with addition and subtraction because we're moving backwards, and because we're doing algebra and we're doing things to both sides of an equation. But remember too, when we have a squared in an equation, that usually means that our rules of algebra are slightly different from what we first learned when we learned algebra. Normally we learned to isolate x to get x alone, but with a squared, we actually want to bring everything towards the x because there's just too many kinds of x's. So we're kind of stuck if we don't do this. So instead of getting x alone, we want to bring everything towards it, and we actually want to get one of these sides equal to 0. And the easiest thing to do is to move the 2 pieces that are on the left over to the right. So we are doing addition and subtraction here. I'm making zeros. X minus x is 0. 15 minus 15 is 0. So this whole side is just 0. And then here we have x squared plus 5x, and that is minus 6. So addition, subtraction, done. Is there any multiplication or division to do? No. Is there any exponents or radicals to deal with? No. I can't do anything with that squared because there's other stuff going on. So I can't really handle that. So now we get to another kind of annoying step that comes with complex algebra. We have a grouping that we want to make, right? We have this thing with groupings where we sometimes have to break them apart like we did before, but other times we have to make them. And if you really get good at algebra, you're going to be able to recognize the difference. And it's not always, intuitive at first, but yes, sometimes we want to make groups. Other times we want to break groups. You have to just keep practicing. Here, I want to make groups because I want to factor, because the only way to solve this x squared equation really is to break it apart. So we're going to have an x and an x. Remember, we need things that multiply to -6 and add to 5. So we're going to have 1 positive, 1 negative. Let's do 6 and 1. Does that make sense? 6 minus 1 is 5. 6 times -1 is -6. So all is good. And now basically we've done the group, but now we have new groups that we can kind of work on to solve. And the whole point of doing this is that basically what we end up doing is creating two very simple equations, x plus 6 equals 0 and x minus 1 equals 0. And now these mini equations can be solved in the more traditional way that you learned algebra. Let's get x alone. So again, there's another GERMDAS we're kind of doing here, but thankfully these equations are so simple, we don't even really need to think of the other steps. We're working backwards again to get x by itself, and addition and subtraction comes first. So -6 from both sides, we get x equals -6. Add 1 to both sides, and we get x equals 1. So at first, it might seem we've got the answers. There are two solutions, right? And so what could we have done differently to get this faster? We could have gone to Desmos. And if we type this equation in just perfectly without any errors, the same way we got it, right? Without even simplifying anything, even the easy stuff, the Desmos calculator is going to graph for us a straight line with the answer. And you can see we have a straight line, but only one, right? Where is that one? It's at 1. So this is a solution. What happened to the -6? Why isn't there a line at -6? Well, that's because it's an extraneous solution. And you probably learned about this in maybe your pre-calc class if you're there, or maybe even on Algebra 2 if you did that. It basically means that sometimes we can do all the algebra correct, all the simplifying correct, and yet the equation will spit out a number that isn't really a solution. And that happens a lot with radicals because of just the way they behave. So what technically, if we didn't have a calculator here, what we would need to do is go back to the original equation and put in -6, and it won't work. And I'm going to show you that because we're trying to do GERMDAS, we're trying to be thorough. I'm not going to do it with the x equals 1, but basically it's the 1 would work and the -6 would not. And that's why we get a line in Desmos at the 1 and not at the -6, is it's telling us that's not a real solution. So thankfully, if this is the SAT, we don't even need to do any of this work. Plus, we also don't need to worry about the careless mistake, the trap mistake of having the extra solution, the extraneous one. So let's go to Desmos, or let's go back to the page, and we're going to just plug in the x equals -6 to this equation. So let's just rewrite it. So we have radical 10 minus 6 plus 5 minus 1. Oops, see, careful. That's not over the 1. That's just over the 5. Equals 2 times -6 plus 7 minus -6 plus 12. Now, I'm going to just do GERMDAS, but I'm going to do it on both sides, right? So let's kind of stick one up here, GERMDAS, and GERMDAS over here, because now, notice, there's no variable, so we're not going to ever do algebra here. We're just simplifying. So are there any groupings? Yes, we have a grouping right here. Let's simplify it. 10 minus 6 is 4. 4 plus 5 is 9. So radical 9 minus 1. Are there exponents and radicals? Yes, we can do radical 9. That's 3. 3 minus 1. Is there any multiplication and division? No. Is there addition and subtraction? Yes. 3 minus 1 is 2. Now remember, when we have a radical symbol in an equation, it only produces the positive result. It does not produce the negative result, even though sometimes when you take radicals, you need to care about the positive 3 and the negative 3. But when the radical symbol is in the equation itself, we only deal with the positive one. So we got the left side as a 2. What happens on the right side? Okay, well, same thing. Let's do GERMDAS. Do we have any groupings? Yes. And now those groupings, those parentheses that before we had to like distribute and deal with all sorts of weird things, now we can just do what's in there because we have a number in there. So -6 plus 7 is just 1. And then -6 plus 12 is 6. So the groupings are done. Do we have any exponents or radicals? No. Do we have any multiplication or division? Yes. 2 times 1 is 2. And do we have any addition and subtraction? That's our last step. 2 minus 6 is -4. And this is now proof of why -6 is not a solution. We get a result that doesn't make sense. 2 equals -4? No, it does not. Now, if we were to, do this exact same thing for the x equals 1, I promise you we would get, I believe, 3 equals 3. That is proof that we have a good solution because 3 does equal 3, right? That works. But again, we really would not want to do any of this on the SAT if we could avoid it. We'd rather just type something that's this crazy into Desmos. But the SAT is so good at finding places where maybe we can't use the calculator, but we still need to know all these complicated GERMDAS rules. So if you can solve an equation like this without the calculator, then you are very prepared for whatever algebra we're going to see on the SAT. This is very complicated. So if you're not at this point, my advice is use the calculator as much as possible, because you do not have an intuitive sense of when we're simplifying, when we're solving, what the order is, what the moves are, how to make and break groups. There's a lot of stuff that comes from this. This is a language, and basically you are not yet literate in the language of algebra. GERMDAS is kind of that structure, that grammar that allows us to know which steps to do in which order. And I don't really have to think about it much because I've been doing this for a long time. So eventually you want to get to that point as well. But for now, if your SAT is just in a little bit of time, then, use the calculator. But if things are simple, you still should be thinking about GERMDAS to solve those simple things in the right order. Hopefully this helped. I know it's complicated and frustrating, but hopefully it made some sense.